Uh, so, so let me first go through our course syllabus and our grading policy, and then we will kickstart our class. So let me share the screen with you. So I have already made our EE340 course available on Blackboard. So you are seeing the screen, right?
Yes.
Okay.
Yes.
Yes. So this is our course screen on the Blackboard. Now, as you can see, here are all my details. My office hours is Sunday, Tuesday, 11 to 11:50 a.m. and Monday, 10 to 10:50 a.m. And also you can send emails and we can fix an appointment. And the office hours is again on Zoom, and we have a separate link. So if you see this red one, so this red one is the separate link for the office hours. And this is the meeting ID and this is the passcode. So if you want to meet during the office hours, you have to join on this link. Our classroom, if you see here, this is our classroom Zoom link details. This, if you click here, it will directly take you to the classroom, and here you can see the meeting ID and the passcode. It is extremely important, guys, that you log in with your first name and last name. This is very important for me to identify you. And also in future, we are going to have class interactions. So during the class interaction, Zoom will capture your name in the Excel sheet. So it should be easy for me to identify your name. That's why. Now, if you see here, you have all the course material will be put here and the assessments are here. So in the course material, first, let's go to the course syllabus. This is the course syllabus. So we have 3 sections of EE340 going on. So I'm taking 1 section and 2 sections are taken by Professor Hussain Masoodi, and he is the coordinator of this course. So therefore, these 3 sections, we are going to have our common exams. Now, if you see here, these are the topics that we are going to cover in the 15 weeks, and these are the sections of the text. And the textbook that we are following is Sadiku, 6th edition. I'm going to show the textbook in a while. Okay, and these are the sections of the textbook that we are going to cover. These are the sections which are excluded. So we are not going to cover this. And this is the tentative assessment plan. So if you can see here, but I will inform you if I'm conducting any quiz, I will inform you 1 week in advance. So there is a possibility that, we move the quizzes or the assignments, here, 1 week here and there. Now let's go to the grade distribution. So if you see here, you have a laboratory, which is 20%, and we are going to have a midterm exam, 22%, and the final exam, which is 30%, and it will be comprehensive. As of now, our plan is to conduct the midterm exam and the final exam physical. These are the instructions from the university. So we will update you as the situation or as the time progress about the midterm exam. And also, if we are reverting back to a virtual platform to conduct the midterm and the final exam, then there is a possibility that we might alter the grade distribution. Okay, so we will update you accordingly. The classwork is 28% is the classwork. So where we have 10% quizzes. Quizzes will be mostly virtual online quizzes. And I'm going to conduct 4 quizzes, 1, 2, 3, and 4. So I'm going to conduct 4 quizzes. Then you will have a project, which will be a design problem. And this design problem, it will be given in week 10 or week 11. So the design problem is basically, it's a problem where you will use the knowledge that you have acquired within this course to design some circuit or to design a circuit, some other, to identify some parameters which uses the concepts of electromagnetics. And then you will have assignments, which will be 6%. And these assignments, there are 4 of them, if you see here. And these assignments will be composed of 4 to 5 problems. And you will be given around 1 week to submit the assignments, 1 week or 10 days. Then the last part is the performance, which is 6%. Now, this performance is very important. As you can see, it is based on class interaction and attendance. So class interaction here, what I'm going to do is I'm going to say conduct some random questions during the class. And this, I will either do it via the Zoom poll feature. So where I will have a pop-up question and then you need to select an answer, or I can verbally ask any question and I will ask you that you answer them in a private message. Okay, so this will be the class interaction. And in a week, in 1 week, I might ask 1 to 2 questions or even more. And in some weeks, I can even skip asking the questions. So in the end, I'm going to accumulate all these questions and those who have answered it correctly and those who haven't. And based on that, you will get the 6% on the performance. Now, attendance, this is the policy that I always keep for my attendance. So for me, up to 3 unexcused absence, I do not mind. Okay, because there can be some emergencies and so unforeseen circumstances, so it's fine for me. Okay. But after this, I cannot accept. So after this, for any unexcused absent, I'm going to deduct minus 0.5%, and this minus 0.5% will be from your performance. Okay, so this is how the classwork is. And since it is a coordinated course, again, as you are aware, the classwork will be normalized. So we have 28%, and the 75% of 28 will be 21. So we will normalize this 28 to an class average of 21, and this will be done for all the sections. So this will be the classwork, and midterm and final exam, they will all be common. Now, this is regarding the grading policy. Now, if you see here, you have homeworks. So we have prepared 15 homeworks because this course is a sort of condensed course. There is a lot of materials to cover. So what we will do is we will try to, take few examples and few problems in the lecture, but you will require to do a lot of practice on this in this course. So these practice, I encourage you that you can make use of these homeworks, because these homeworks are not graded. So these homeworks doesn't carry any grade. So what I'm going to do is I'm going to post the solutions of these homeworks as time passes. So for instance, I have already posted the solution of 3 homeworks here. See, in the homework session, I have already posted 3 solutions. So these homeworks are basically meant for you guys to practice as many problems as you can. So these homeworks are from our textbook, Sadiku. Okay. And besides that, there are several examples in the textbook. So I really encourage you to practice as many, problems as possible. This is regarding the, yes, Mr. Basil. Basil, you have raised hand, right? Okay. Okay, done. So this is regarding the syllabus. Mobile phones, please switch off. Homeworks, quizzes, I have already talked to you. All the material will be posted on Blackboard. Attendance, this is my policy. Besides that, the university policy is mentioned here. So please take care of that. Then official excuses, you know it very well that it will be from the student affairs. And this is the last sentence. This is in case if the situation, changes and the situation demands or exams to be conducted virtually and assessments, then we will talk about this last point. Okay. Uh, so this is our course syllabus. Anything you want to ask? No? Okay. So let's then start. So this is our course syllabus. And then this is the lecture PDF files. So these are my notes. So instead of preparing in slides, I have prepared the PDF files, and I'm going to teach you from these notes. But please guys, this doesn't mean that you don't open the textbook. So please, you have to open the textbook, because there are some very good examples which are done in the textbook. So you can do those examples, and the textbook has very good exercise, a lot of problems from the exercise. Some of the problems are in the homework, but there are several problems which are not included in the homework. So I encourage you to solve those problems, and not only from the Sadiku textbook. You can search on internet, you can take other textbooks also, and you can solve from. Okay, so these are my notes which I'm going to post it here. So for example, this is our lecture 1 which I have already posted. So I have already posted the lecture notes of 3 classes, which is of this week. Okay, then you will have the class recordings. So whatever lectures that I am going to teach, I'm going to record and I'm going to post it in this link. Okay. Uh, then you have any extra material if I want, or the extra material I have posted here. So for example, there is a EE340 maths help session here. It's a PDF file. This actually summarizes our chapter 1, 2, 3 of Sadiku, which is the coordinate system and the vector calculus. So I encourage you to just go through this to revise, because it's a long time that you might have taken maths 302. So that's why please go through this help session and just brush up all the coordinate system, which I'm going to do in the class, but it will be very quick. Please go through them, and also go through the vector calculus. Now, the homework solutions are posted here. Then you have the assignments, the class interactions, any poll questions or any questions that I'm going to ask, its results, I'm going to post it here. The assignments, any assignments, I'm going to post it here, quizzes, the design problems, and the midterm and the final exam. Okay, so this is regarding our Blackboard page. Any questions you want to ask regarding the Blackboard page? No. Okay. So let's start. First, let me just show you the textbook. Just a second. Okay. So this is our textbook. Elements of Electromagnetic by Sadiku. This is the 6th edition. We are going to follow the international edition. So the international edition is, excuse me, is more or less the same as this edition. So if you see here, you have.
Doctor, will you post this book?
Good question. Guys, I don't know whether I would be able to post, because if I do that, then the copyright issues will come. So I don't think I would be able to do. But may I know how the bookstore is working? So you should come and pick the textbook from the bookstore.
For
Yes,
those
if
who
you
are
live.
close to the university, can come and pick it.
Okay, so you have to come physically and pick the textbook from the bookstore, right?
Doctor, those who are away from the eastern province or Dahran, about
Yes.
200 kilometers, like me, I'm from Riyadh. I cannot come to the bookstore, and I cannot restore bookstores that I have lent from the bookstore. I have to do that by mail.
By mail, okay. And
But
how
otherwise,
about the new textbooks? Is KFUPM going to mail you the new textbook? They're going to ship?
No, they didn't say it. They said that we will send you an email
Okay,
about it.
okay. Let's just wait and see. You know how they are going to arrange for the new textbook delivery. And in the meanwhile, I will check internally in our department to see, because you know these soft copies we cannot post because it will be under copyright infringement. So that's why we are very careful. Okay. So let's see. So this is our textbook. So the vector calculus part is the first 3 chapters, and this is the review that you know the maths help session is doing. So please go through that, and also you will be reviewed on these 3 chapters in the laboratory, because the first 2 weeks, excluding this week, the second and the third week, you are going to do the problem sessions, and those problem sessions are based on these first 3 chapters and very relevant to what you are going to do in the subsequent chapters. So now we will start from here. Electrostatics. So we have electrostatics here. So chapter 4, 5, 6. These 3 chapters are based on electrostatics. Then we have 2 chapters, 7 and 8, on magnetostatics. Then we have the waves and applications, which is part 4, chapter 9, chapter 10, chapter 9 and chapter 10. Then chapter 11, we are not going to go in detail. We are going to take just one, 3 sections. The remaining sections is removed. For waveguides also, we are only going to take few sections and other sections are removed. And then we will take the first 2 sections of antennas. So electrostatics, magnetostatics, and this chapter number 9 and 10 are nothing but the electromagnetic waves. And chapter 11, 12, and 13, we are just trying to give you the flavor of the applications. So all these 3 chapters, 11, 12, and 13, are the applications of our electromagnetics. And if you see here, so so this is our chapter 5, which we are going to start. Sorry, chapter 4, which we are going to start. So if you see here, there are several examples also. You know, example 1, example 2, examples are there, and also some practice exercises there. And at the end of each chapter, you will see that you will have the exercise. You also have the application note, how you know, at the end of every chapter, you have this application note. That is how, what, you know, these the topics that you have studied, how it is applied in other applications. So I encourage you to just read through it, because unfortunately, you know, for us as an instructor, we might not be able to cover it because of, you know, the course syllabus. We have to complete the course syllabus on time, and this electromagnetic, it's quite condensed course. If you see here, so the exercise, the problem starts from here. So if you see, it is 4.1, and it also gives, according to the sections, the problems. So there are very good number of problems. So if you see here, almost 64 problems. So you can go and you can practice, not all, but at least few of the problems. And besides that, you also have some review questions, which is a sort of multiple choice. You can also do these if you want. So every chapter has good number of problems and good number of examples. Okay, so this is our textbook. Now let's start our class. So our first lecture, so where I'm just quickly going through the coordinate system. So we have the three types of coordinate system that we are going to use it in our course. So the rectangular coordinate system, the cylindrical coordinate system, and the spherical coordinate system. And remember, our rectangular coordinate system is right-hand rectangular coordinate system, that is uses the right-hand rule to identify the X, Y, and Z directions or Z axis. And a point is represented by X, Y, Z, or in cylindrical, it is rho, phi, Z, and in spherical, it is R, theta, and phi. And any vector is represented as the AX and small ax. So our Sadiku book, it uses this small ax with an arrow as the unit vector along the x-axis. So this is the notation that is used in Sadiku textbook. So this is the unit vector along the x direction, unit vector along the y direction, unit vector along the z direction. And for cylindrical, it is a rho, a phi, a z. And for spherical, it is AR, A theta, and A phi. So any vector, if you want to represent in a space, you have to first, look at that space from the mathematical point of view. So in order to look any space from the mathematical point of view, you have to visualize that space in any of these coordinate systems. And after you visualize that space in any coordinate system, then you can locate any point in that space or any vector in that space. And that is the location or the vectors, they are represented in, the points are represented in this manner and the vectors are represented in this manner, where these are the unit vectors in these three different directions, and this capital AX, capital AY, capital AZ, or A rho, A phi, AZ, you can say this is the component of the vector which is along the x direction. This complete is called as the component of the vector A along the x direction. This is the unit vector, and this is the the magnitude of the vector A along the x direction. Now, how they are represented? They are represented, any point is represented in this way. I will show you another PowerPoint to explain this further. So as of now, I will just skip it and I will just tell these ones. So in rectangular coordinate system, your X, Y, and Z, they can go from -infinity to +infinity. But for cylindrical and spherical, your rho can go from 0 to infinity and phi can go from 0 to pi, and r can go from 0 to infinity and phi can, theta can go from 0 to pi. And here z is same as your rectangular coordinate z. And here phi is same as your cylindrical coordinate phi. Now, what are these? Let me just show you in a PowerPoint. Okay, so this is the PowerPoint. So this is my rectangular coordinate system. So if you see here, so this is the rectangular coordinate system. So these are the constant planes. So this is X, Y, and Z. And remember, the X, Y, Z, the directions of the X, Y, Z is identified with the right-hand rule. And these are the constant planes. You can see this is the X constant plane. So X constant plane. So this is the plane in which the value of x is constant. So this is nothing but your YZ plane where x is constant. Similarly, you have the y constant plane and the z constant plane. And any vector a bar can be represented, as I told you, in this form, or sometimes people write it in bracket as ax, ay, az. So this is your unit vector directions. If you see here, this is nothing but it is a unit vector. So the name unit vector is because its magnitude is 1. So this is the unit vector along the x, unit vector along the y, and unit vector along the z direction. Okay, and these are any surfaces. If you want to find the surfaces, then what you do, you put a small cube and you assume that the sides of this cube are infinitesimally small, dx, dy, and dz, and then you can find the area. So the surface areas, ds, which is a vector, you can identify. So for example, if you are looking for a, b, c, d, then this area, it will be what? It will be dx, sorry, it will be dy, this is dy, and this is dz. So the area will be dy multiplied by dz. And what will be the unit vector for this particular area? So for a surface area, the unit vector will always be perpendicular to that area. So the perpendicular one to this area is ax. So it is dy, dz, and the unit vector which is perpendicular is ax. So that's why it is dy, dz, ax. Similarly, you can get it for others. Okay. Now, phi is called as azimuthal angle and rho is called as the radial distance in cylindrical coordinates. And how to visualize this? See this one. So this is your cylindrical coordinates. So it, unlike your Cartesian coordinates or rectangular coordinates where you have constant x, y, z plane which are flat, but here it's not the case. So in the cylindrical coordinates, you have the 3 planes, but one plane is the cylindrical plane and the other plane is a rotating plane, and the third plane, which is this blue one, is nothing but your the
z-axis.
Yes, excuse me. The very similar to what you have for the Cartesian coordinates. So it is nothing but you can think it as your the xy plane, or where your z is constant. So it's a constant z plane. So the green one is your cylindrical plane, which is nothing but the radius of the cylinder. The radius of the cylinder is your rho. The radius of your cylinder is your rho. So if you see here, sorry. So the radius of the cylinder. So if you want to identify any point here, so this point, its distance from the origin to this point is nothing but rho. And that rho is the radius of this cylindrical surface. Because this point is on the cylindrical surface. This point is something like this. So it will be on the cylinder like this. And the radius of that cylinder, so this will be the radius of that cylinder. Then you have phi. So how do you define phi? Phi is called as the azimuthal angle, or just a second, let me remove it. Otherwise, it will stop. Okay. So phi is nothing but it is telling you the angle of this rotating plane. So, and this rotating plane angle is always measured from the x-axis. So in this case, the rotating plane is nothing but its position is this one. This is the position of that rotating plane. And How do you identify it? You identify it from the x-axis, and this angle is nothing but it is phi, which is called as the azimuthal angle. So you require rho, you require phi, and you require z. Z is nothing but your z plane, this blue plane, and this blue plane is nothing but it is here, and this value is your z value, and this will define your point in space using cylindrical coordinates. Okay, so this is how the cylindrical coordinate looks like, and you can go through, how do you convert from cylindrical to rectangular coordinates, and how do you find the unit vectors. Just a small comment on this. How do you identify the unit vectors in a cylindrical coordinates? It's very, for rectangular coordinates, it was very easy because your x, y, and z, their directions were fixed. So wherever you go in space, the x direction, y direction, and the z direction will be the same. But now if you see here in cylindrical coordinates, you need to be a little bit careful. First, how are the unit vectors? Let's see here. So this is just a part of that cylinder. Okay, so this is your radius of the cylinder rho. So the unit vector along the rho direction is this one. See, this is the unit vector along the rho direction. So because this is your rho, so your rho is this is your unit vector, and this unit vector, if you see, is perpendicular to the cylindrical plane. This is your cylindrical plane, right? And this is perpendicular to the, or normal to that cylindrical plane. I would say normal because I'm talking about surface. So it's normal to that plane, A rho. But here there is a catch, which is very, very important. Now this A rho, the unit vector A rho direction will not always point here. It can move, right? The unit vector direction, it can move. What I'm trying to say, I'm trying to tell you that, okay, so if I take a point here, or if I take a point here, that this is much easier. Then what will be the direction of your arrow vector? Then your direction of your arrow vector will be this. This will be arrow. See? And if you take a point here, then the direction will be in this manner. And if you take a point here, the direction is this. So your unit vector arrow, its direction changes as you move in the space. This is unlike your Cartesian coordinates, because in Cartesian coordinates, wherever you move in the space, your x or your unit vector will always point along x direction. The unit vector y will always point along y direction, and the unit vector z will always point along z direction. But here it's not the case. That's why the spherical coordinates, dealing with them is a little bit difficult. But once you understand this part, it becomes much easier. So therefore, this arrow will change their directions according to where you are in the space. So this is your arrow. Now, how is the a phi vector? Now, the a phi vector should be perpendicular to this phi. What is this called? This is called as a constant phi plane. So this is the rotating plane, and this is making an angle of phi here. So wherever you take a point on this plane, it will have a constant phi value. So that's why it is a constant phi plane. It's a constant phi plane. And this part of this cylinder was your constant rho plane, because wherever you go on this part of the cylinder, your rho is constant. Your rho is constant. Okay, so yeah, we are running out of time. Let me just quickly summarize this. So I'm talking about the phi plane. So this is the yellow one, and this is the unit vector which is normal to this phi plane. So it is a phi. And again, you see, as this plane rotates, your a phi will change the direction. For instance, what will be the a phi direction for this one? Suppose this yellow plane is rotating, and I'm now looking at this point. So for this point, your phi is 0 because you have to take with respect to x-axis, your phi is 0. So what will be the unit vector a phi? This will be the unit vector a phi. So here its direction is in this way, but here for this point, its direction is in this way. So therefore, wherever you go in space, your arrow and a phi will change the direction, but az will be the same, because here also az will be pointing upwards. Here also the az will be pointing upwards. Or if you take this point also, the az will point upwards. So wherever you go in space, your az will be the same. Okay, so this is for the cylindrical coordinates. So this you need to understand this. And these are the rules which you guys are very well aware. Then for the surfaces, we do the same thing. We take a small infinitesimal area and then we can find all the surfaces. So please, go and look at it. How do you find this? And as it comes in any problem, I will then quickly I will just go back and then quickly review this. And for the spherical coordinates, so this is r is again the radial distance. This is theta and this is phi, and it is something like this. See, this is your spherical coordinates. So your now cylinder is replaced by a spherical surface, and this is the spherical surface, and the radius of the spherical surface is your r. Then this rotating plane is the constant phi plane. It is same as your cylindrical one. Now there is no z here. There is another plane which is nothing but a cone. See? So the cone will start from z-axis and expands and then returns back here. And this is your angle theta. So theta is the half angle of this cone, and it is taken with respect to z-axis. So it starts from 0, goes to 90 degrees, and then to 180 degrees. So when it is 90 degrees, it's a plate, circular plate. So that's why it is from 0 to pi. And phi, it can rotate from 0 to 2 pi. And r is the radius of the sphere. So that's why it starts from 0 and it goes to the infinity. Okay. And then you have again the small spherical, the infinitesimal area. You can find the different surfaces, and then you can find the volume. Okay. So we will stop here, guys. And then in the next class, we will start our electrostatics.